I'm hungry. Go make me a sandwich.
Make your own sandwich. I don't know how to cook.
I know how to cook. I'm a master chef. I can make a sandwich in 15 seconds.
Shenanigans.
We can use stats. Hi, I'm the Stats Fairy, and I'm here to help those fools through 2 significant tests.
You ready?
Any day.
Alright. 3, 2, 1, go.
During this test, we have the null hypothesis being Trevor's theory, in which he can make a sandwich in 15 seconds. However, we have Walker's theory in the alternative hypothesis, in which Trevor can make the sandwich in greater than 15 seconds.
Should have shot for 30.
You know what we need? We need more trials.
Oh, I have proof right here. You didn't make 15.
It's one time. Do it again.
Okay.
Are you ready? 3, 2, 1, go.
It's very important to remember the conditions of a t-test. First, we have independence, and in this case, each sandwich is independent, and there must be an SRS, or a simple random sample, and here there was a random selection from the market of ingredients. Finally, normality, which is the probability has to be greater than 30. In this case, we only have n equals 5, but we can still continue, just with caution.
Oh yeah, in your face.
We did our calculations using the t-test formula, which is shown on right here, and we ended up with a t-value of 2.170. And looking up in our table using degrees of freedom of 4, we ended up with a p-value of 0.045. Now for our conclusion. Since our p-value is 0.045 and it's less than the significance level of 0.05, we can reject the null that Trevor can make a sandwich in 15 seconds. Therefore, we have enough evidence to prove Walker's theory, and that it takes Trevor longer than 15 seconds to make a peanut butter and jelly sandwich.
So we can conclude with 95% certainty that you suck at making sandwiches.
Hey, I was pretty close.
95%.
Well,
We're mad.
at least I can make sandwiches faster than you.
Burn it. I don't believe you.
We have a challenge.
This time, our hypotheses are Trevor's time equaling Walker's time. However, the alternative hypothesis is Trevor's time being less than Walker's time. Even though this significance test is a 2-sample t-test, the conditions are the same. Independence, where our sandwiches are independent. Simple random sample, where we have a random selection at the market. And normality. And again, the n equals 5, so it's less than 30, but we will still continue with caution. For our calculations, we used the 2-sample t-test formula, and when we plugged everything in, we got a t of negative 9.601, and using our table and a degrees of freedom of 4 again, we found a very small p-value. Our conclusion is to reject the null hypothesis that Trevor's time and Walker's time equal each other, since our p-value is so low. Therefore, it is under our significance level, so we can do this, and there is enough evidence to show that Trevor's time is less than Walker's time.
We can conclude with statistical significance that Trevor's time was much faster.
In your face.
In your face. I conclude with 100% certainty that now I make the faster sandwiches.